In a right triangle ABC, right angled at C, M is a midpoint of the hypotenuse AB. C is joined to M and produce to point B such that DM equal to CM. Point B is joined to B. Prove the following. Let's mark some things that we need to know. We start from this. M is a midpoint of the hypotenuse AB. So here M is a midpoint of AB, which means we can say here this equal to this, AM equal to BM, because M is a midpoint. And in this also they say DM equal to CM. So we'll mark that too. So here DM equal to CM. We mark this. We'll take up the first part, and the first part is this: to show these two triangles are congruent, which means to show triangle AMC, this is triangle AMC, is congruent to this triangle BMD. To show these two triangles are congruent, and I think it's quite simple. We have S, and then we have this A equal to this A. So by SAS test, these two triangles are congruent. So we take these two triangles. So we have statement, we write the statements. This whole sum is done in a couple of parts. It's a long sum. So first we will say BM. I think we'll write first AM equal to BM. Reason: M is midpoint of AB, first point. Then in the next we have written MC equal to DM. Here this is given to us, and then we have the vertically opposite angles. So we have angle AMC equal to angle DMB, and that is vertically opposite angles. So here this was a S, and this was S, and this was A. So we have S, A, S test. Here to S, A, S test. The triangles are congruent. So we'll write triangle AMC is congruent to triangle BMD, and this is by SAS test. Here we need a few CPCTs, which we'll check out now. So we have shown these two green triangles, congruent, and we require a few CPCTs for this. Now here we already know, that we can say this one DB equal to AC, which we will use later on in the data part, this equal to this by CPCT. So let's write that out. We have BD, and remember this equal to AC by CPCT. We will put 1. And we can also say these two angles are equal. This angle is equal to this angle. Which is that angle? That is angle BDM equal to angle ACM, also by CPCT. But if you are very careful, you will notice that these two angles, if these two angles are equal, therefore these two lines are parallel. Which line? This line. This become alternate angles. Have you seen? They become alternate angles of these two lines. So I can say these two lines are parallel. This line is parallel to this. So now I can write BD is parallel to AC. Reason: the alternate angles are equal. So to go back again, we did CPCT. Now this information we will use later, that BD equal to, and this was by CPCT, and we also are going to use the fact that these two lines are also parallel because we can say this angle equal to this angle by CPCT, and they happen to be alternate angles, therefore the lines are parallel. So the second thing we need to prove is DBC is 90. If you remember, we went last time in the first part, we showed that these were parallel, right? We showed DB was parallel to AC. So we'll just write that out. So we already proved that BD parallel to AC, proved earlier. Now if they are parallel, let's mark our co-interior angles. So this angle and this angle, they form that U. We have this entire U like this, right? So I can say now angle DBC plus angle ACB equal to 180. Reason? Co-interior angles. These are co-interior angles. Here I have my U. This is my U of my parallel lines. And these lines are parallel. This is parallel to this. So this angle plus this angle will be 180. And now we also know that one of this angle is given as 90. This angle is already given as 90. So DBC plus 90 equal to 180. So angle DBC equal to 180 minus 90. Angle DBC equal to 90. So second part we have proved that DBC is 90. And you got to remember that DBC is 90 because we need to use it in the next part. Just to repeat this again, this was already proved parallel. And then we had the transversal here. Therefore, these two angles, when you add up this angle plus this angle was 90. We already know was 180. We already know this is 90. Hence, this also has to be 90. The third that we need to prove is DBC congruent to triangle ACB. Let's mark what we know first. We already have known that these two are equal. We already showed this was equal to this. We already proved this up. We already showed that this was 90 in the earlier one, and this is also 90 we have shown. And you definitely know this is common. Here I have this common. So which two triangles can be shown to be congruent? I can show this triangle, that is DBC, this entire triangle DBC will be congruent to this triangle ACB. By which test? Why will these two triangles be congruent? The orange and the gray one, and that's easy to understand. This is S equal to this A equal to this A, and this S is common. So by SAS test, these two triangles will be congruent. So let's write the statements. So here we take triangle DBC and triangle ACB. So the statements. So first we are going to write here that BD equal to AC, which we have proved earlier. I'll just repeat now just to make, I have shown this one here. See, this is equal to this. We have proved already earlier. Then we show the 90. This equal to this angle. So we'll write that. So we'll write angle TBC equal to angle ACB equal to 90. This was also proved. And now we have BC equal to BC, and that is common. So triangle here, triangle DBC is congruent to triangle ACB by SAS test. This is the S here, S, this is the A, and this is the S. By SAS test, they are congruent. Now we go to the fourth part of it. If these are congruent, I can say DC equal to AB. So DC equal to AB by CP CT. Now look up at DC. This is my DC. This is DC. And DC is made up of, if you see, DC is made up of DM plus MC is equal to AB. Now DM and MC are equal because M was the midpoint. It was given right in the beginning. It was given to us that DM equal to MC. So here I will write MC plus MC equal to AB. So twice MC equal to AB, and MC or CM is half of AB. So the reason here why I did this is this. For this DM, I wrote MC because DM was equal to MC. So here I prove the fourth part. This proof has to be studied in parts. So I'll just go over the summary. In the first step, we took these two triangles and proved that they were congruent. We took these by this equal, this was equal, and this was equal. So these two triangles were equal to S test. Then from there we got by CPCT, and we said that these two were equal by CPCT, and we also had this angle equal to this angle. Therefore these two lines were parallel. All we proved this by CPCT of the green triangles, of this green triangles. There was a CPCT of these, of the green triangles. Then after which we showed that both these angles, because they were now parallel, we showed these angles were 90. This angle we said was equal to this 90. And then we showed these two triangles were congruent. This triangle here, this yellow triangle, was congruent to this blue triangle. We showed these two congruent. Again, this also by SAS. We had this already shown earlier. That was the S, then this was the A, and this was the S. So these two triangles were congruent by SAS. And because of which, then we got AB equal to DC by CPCT. We had AB equal to DC by CPCT, and then we did AB for DC. We saw DC was twice CM because this was midpoint here, this was midpoint, and we had these two equal. So we had this was AB, and so we had CM equal to half AB. It's one of the longest proofs of the NCERT, but you have to study it in parts.